Welcome to the wonderful world of chemistry. Chemistry is all around us, from the air we breathe to the food we eat. It's a fascinating subject that helps us understand the world at a molecular level. Today, we are going to learn about one of the most fundamental concepts in chemistry known as the mole concept. This concept is essential for anyone who wants to delve deeper into the subject and understand how chemical reactions occur. Don't worry, it's not as complicated as you might think. In fact, once you get the hang of it, you'll find it quite intuitive and useful. The mole concept simplifies the way we count and measure atoms and molecules, making complex calculations much more manageable. Once you understand it, you'll be able to solve a wide variety of chemistry problems. Imagine you're baking cookies. You need to measure out ingredients like flour, sugar, and butter to get the perfect batch. You wouldn't measure out flour in individual grains, would you? That would take forever. Instead, you use a more convenient unit like a cup or a tablespoon to measure the flour quickly and accurately. Instead, you use a more convenient unit like a cup. This makes the process of baking much simpler and more efficient. Similarly, in chemistry, we use the mole as a unit to measure large quantities of tiny particles. The mole is like that cup in chemistry. It allows us to count atoms and molecules in a way that is practical and easy to understand. 1 mole is equal to 6.022 x 10 circumflex 23 particles, which is known as Avogadro's number. It helps us measure incredibly small particles like atoms and molecules. Without the mole concept, it would be nearly impossible to work with such tiny entities in a meaningful way. Are you ready to learn more? Let's dive in. By understanding the mole concept, you'll unlock a new level of comprehension in chemistry, making it easier to grasp more advanced topics and perform accurate experiments. In chemistry, a mole is simply a unit of measurement. Just like we have a dozen or 12 for things like eggs, we have a mole for counting atoms and molecules. A mole is a very large number, represented by Avogadro's number. A mole is defined as the amount of substance that contains as many elementary entities, atoms, molecules, ions, electrons, and so on, as there are atoms in 0.012 kilogram of carbon-12. Avogadro's number is a very important constant in chemistry. It is named after the Italian scientist Amedeo Avogadro, who made significant contributions to the development of the mole concept. Avogadro's number is approximately 6.022 times 10 to the power of 23. That's a huge number. It means that 1 mole of any substance contains 6.022 times 10 to the power of 23 entities of that substance. For example, 1 mole of water, H2O, contains 6.022 times 10 to the power of 23 water molecules. Section 4. Why is the mole important? The mole concept is crucial in chemistry because it allows us to connect the macroscopic world we live in with the microscopic world of atoms and molecules. It provides a bridge between the mass of a substance and the number of entities in that substance. Using the mole concept, we can convert between the mass of a substance, the number of moles, and the number of entities like atoms, molecules, and so on. This is essential for stoichiometry, which is the study of the quantitative relationships between reactants and products in chemical reactions. Section 5. Relationships involving moles. In this section, we will delve into the fundamental relationships that involve moles, a central concept in chemistry that helps us understand the quantitative aspects of chemical reactions and substances. There are 3 key relationships involving moles that you should be familiar with. These relationships are crucial for solving problems in chemistry and for understanding how substances interact on a molecular level. First, moles and mass. The mass of 1 mole of a substance is called its molar mass. This relationship allows chemists to convert between the mass of a substance and the number of moles, which is essential for preparing solutions and reacting substances in the correct proportions. It is expressed in grams per mole, g-mole. For example, the molar mass of water, H2O, is approximately 18 grams per mole, meaning 1 mole of water weighs 18 grams. The molar mass of an element is equal to its atomic mass, which can be found on the periodic table. This makes it easy to determine the molar mass of elements and simple compounds, while the molar mass of a compound is equal to the sum of the atomic masses of its constituent elements. For instance, the molar mass of carbon dioxide, CO2, is the sum of the molar masses of 1 carbon atom and 2 oxygen atoms. Second, moles and number of entities. We know that 1 mole of any substance contains Avogadro's number of entities. This number, 6.022 x 10 circumflex 23, is a fundamental constant in chemistry and represents the number of atoms, molecules, or ions in 1 mole of a substance. We can use this relationship to convert between moles and the number of atoms, molecules, or ions. For example, if we have 2 moles of a substance, we can calculate the number of entities by multiplying 2 by Avogadro's number. Third, moles and volume. For gases at standard temperature and pressure, or STP, 1 mole of any gas occupies a volume of 22.4 liters. This relationship is particularly useful in gas law calculations and helps us understand the behavior of gases under different conditions. This is known as the molar volume of a gas. By understanding these 3 key relationships involving moles, you will be better equipped to tackle a wide range of problems in chemistry, from stoichiometry to gas laws and beyond. Section 6. Solving mole problems. In this section we will delve into the fascinating world of chemistry and learn how to solve problems involving moles. Understanding moles is crucial for anyone studying chemistry, as it forms the basis for many calculations and concepts in the field. Let's solve a mole problem together to see how these concepts work in practice. By working through an example, we can better grasp the steps involved and the logic behind them. Problem. Calculate the number of moles in 10 grams of water, H2O. This is a common type of problem that helps us understand the relationship between mass and moles. Solution. First, find the molar mass of water, H2O. The atomic mass of hydrogen, H, is 1 gram per mole. This means that 1 mole of hydrogen atoms weighs 1 gram, and the atomic mass of oxygen, O, is 16 grams per mole. Therefore, 1 mole of oxygen atoms weighs 16 grams. So, the molar mass of water, H2O, is 2 times 1 gram per mole, plus 1 times 16 grams per mole, which gives us the total molar mass of the water molecule, which equals 18 grams per mole. This means that 1 mole of water molecules weighs 18 grams. Next, use the formula. Number of moles equals mass divided by molar mass. This formula is fundamental in chemistry and allows us to convert between mass and moles. Finally, plug in the values. Number of moles equals 10 grams divided by 18 grams per mole. By performing this division, we can find the number of moles in our sample, which equals 0.56 moles. This is the final result of our calculation. Therefore, there are 0.56 moles in 10 grams of water. Understanding this process is essential for solving more complex chemistry problems and for a deeper comprehension of the subject. Section 7. Practice makes perfect. Now it's your turn to practice. Practice problem. What is the mass of 2 moles of carbon dioxide, CO2? Remember to use the molar mass of carbon dioxide to solve this problem. Good luck!